June 7th, 1944. The churning waters off Normandy's coast glittered under early morning light as Lieutenant Commander Philip Mercer stared at the empty horizon from the deck of the HMS Battler. Just 24 hours earlier, these same waters had carried the greatest invasion force in military history toward Hitler's Atlantic Wall. Now Mercer waited for something that even many senior Allied commanders considered impossible: the arrival of an entire artificial harbour, constructed in secret back in England and about to be towed across the treacherous English Channel. "By this time next week," Mercer noted in his log, "we'll be unloading Sherman tanks directly onto French soil without a single natural port." History would prove his confidence both correct and utterly insufficient. Within just 12 days, American ingenuity would accomplish what German military planners had deemed logistically impossible. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how American engineers transformed military logistics forever by solving the greatest challenge of D-Day, not just landing on the beaches, but sustaining the massive flow of men, vehicles, and supplies necessary to push inland against determined German resistance, all without access to a major port. What unfolded over those 12 frantic days would reveal how industrial might, combined with engineering innovation, could overcome even the most formidable natural and military obstacles. The Normandy coastline, with its wide tidal range and exposed beaches, had been deliberately avoided by military planners for centuries. Major General Percy Clarkson, head of the 5th Engineer Special Brigade, surveyed the beach designated as Omaha from the deck of USS Samuel Chase on the morning of June 7th. The previous day's landings had succeeded, but at a terrible cost. Bodies still washed ashore with each incoming wave. Clarkson's attention, however, was fixed on a more immediate problem. "The weather report says we have perhaps 3 days before the next storm system arrives," reported Captain James Walton, standing beside him. "Without the Mulberry in place by then, we'll lose nearly 70% of our supply capacity." Clarkson nodded grimly. "Then we'd better hope our British friends were right about these prefabricated harbours. Otherwise, this beachhead becomes a death trap." What few civilians understood then, or now, was that the successful invasion of Normandy depended less on the dramatic initial assault and more on the unglamorous logistics that followed. The Allied forces would require 100,000 tons of supplies every day to maintain their advance: ammunition, fuel, vehicles, food, and medical supplies. Without a working harbour, the invasion would stall and potentially collapse. German Field Marshal Erwin Rommel had understood this vulnerability perfectly. "The first 24 hours of the invasion will be decisive," he had told his staff in April 1944. "For the Allies as well as the Germans, it will be the longest day." But Rommel's strategic calculus rested on a critical assumption: that the Allies required an existing port to sustain their invasion. This was why the Germans had fortified every significant harbour from Norway to Spain, transforming ports like Cherbourg and Le Havre into virtually impregnable fortresses. But the Allies had devised an audacious solution. If they couldn't capture a port, they would bring their own. 5 miles off the Normandy coast, Captain Richard Crowley of the 401th Port Construction and Repair Group stood aboard the lead tugboat of a convoy unlike any in naval history. Behind him stretched a procession of massive concrete structures and steel platforms being slowly towed across the English Channel. Each component had been meticulously designed and constructed in secret across dozens of British shipyards over the preceding months. "We're towing approximately 144 low-zero tons of concrete and 105 low-zero tons of steel," Crowley noted in his report. "The entire harbour assembly represents more material than the Empire State Building." The scale of the operation was staggering. codenamed Mulberry. The artificial harbour project involved 55,000 workers across England who constructed 2 complete harbours in sections, each the size of the port of Dover, the busiest port in England. The American version, designated Mulberry A, was destined for Omaha Beach, while the British would deploy Mulberry B at Gold Beach. Technical Sergeant Frank Talbot of the 531st Engineer Shore Regiment watched the approaching convoy from his position on Omaha Beach with a mixture of relief and disbelief. 2 days earlier, he had waded through bullet-swept waters during the initial landing. "The beach is chaos," he wrote in a letter never sent. "Vehicles bogged down in sand, supplies piling up with nowhere to go. The tide comes in and takes half our ammunition boxes. We've got 10,000 men ashore and no way to feed them properly unless these harbour sections work as advertised." What Talbot was witnessing was the Allies' greatest vulnerability. By D-Day +1, there were 156,000 Allied troops in Normandy, but barely enough supplies to keep them fighting for 3 days. German Field Marshal Gerd von Rundstedt, Commander-in-Chief of German forces in Western Europe, received intelligence reports of the Allied build-up and remained confident. "Without a functioning port, they will wither on the vine," he told his staff on June 7th. "Their beachhead will become their graveyard." Von Rundstedt's assessment reflected conventional military wisdom. Throughout history, amphibious invasions depended on quickly securing a port. During the Sicily landings in 1943, Allied forces had suffered critical supply shortages despite capturing several small harbours. Analysis showed they would need port facilities capable of handling at least 12,000 tons of material daily to sustain the Normandy campaign, equivalent to the capacity of a major commercial harbour. The genius behind the Mulberry harbours came from an unlikely source, Winston Churchill himself. In May 1942, following the disastrous Dieppe raid, Churchill had written a memo with characteristic directness. "Piers for use on beaches. They must float up and down with the tide. The anchor problem must be mastered. Let me have the best solution worked out." This seemingly simple directive had launched one of the war's most closely guarded engineering projects. British engineers developed massive hollow concrete structures called Phoenix caissons that would be sunk in a precise pattern to create a breakwater. American engineers, led by Brigadier General William M. Hogue, contributed the innovative whale piers, floating roadways that would rise and fall with the tides, allowing vehicles to drive directly from ships to shore, regardless of water level. By the afternoon of June 8th, the first Phoenix units were being positioned off Omaha Beach. Lieutenant Commander Thomas Warfield of the Royal Navy supervised the delicate operation from a control vessel. "Positioning is absolutely critical," he instructed his team. "Each unit must be within 6 feet of its designated coordinates. If the breakwater has gaps, the first storm will destroy everything." The precision required was unprecedented for structures of this size. Each Phoenix caisson weighed up to 6,000 tons and stood as tall as a 4-story building. They were deliberately flooded to sink them into position, creating a solid wall against the channel's notoriously rough waters. Major Robert Davidson of the 497th Port Construction Battalion watched the operation with growing concern about the timeline. "We're placing approximately 1 caisson every 4 hours, he reported to General Clarkson. "At this rate, we need at least 6 more days to complete the breakwater." Weather forecasts indicated they might not have that long. Captain James Stagg, the Allied chief meteorologist, warned of an approaching storm system that could reach force 6 or 7, enough to halt all construction and potentially destroy the partially completed harbour. Meanwhile, the battle for the beachhead continued. The supply situation grew increasingly dire as ammunition and fuel stockpiles dwindled. General Omar Bradley, commanding the American forces, received hourly updates on both the harbour construction and the supply state. The next 72 hours will determine whether we maintain our foothold or are pushed back into the sea, he told his staff on June 9th. Everything depends on getting Mulberry operational. German intelligence had begun to piece together the Allies' harbour strategy. Luftwaffe reconnaissance flights had spotted the massive floating structures, but initial reports were met with skepticism. Rear Admiral Friedrich Ruger, Rommel's naval advisor, reviewed the aerial photographs with disbelief. They appear to be constructing a temporary harbour directly on the invasion beaches, he informed Rommel. Our naval engineers consider this impossible, given the tidal conditions and exposure to the open channel. Rommel, however, immediately grasped the strategic implications. If they succeed, our entire defensive strategy is compromised, he responded. Direct the 8th Air Fleet to concentrate all available aircraft against these structures. But the Luftwaffe, severely depleted by years of war and hampered by Allied air superiority, could manage only sporadic attacks against the Mulberry installations. The German 150-feet infantry coastal batteries near Saint-Laurent attempted to shell the construction site, but their fire proved ineffective against the massive concrete structures. By June 10th, the outer breakwater of Mulberry A was taking shape. Nearly 30 Phoenix caissons were now in position, creating a sheltered area of approximately 200 acres, roughly equivalent to Central Park in New York. Within this protected zone, the next phase began, the installation of the floating whale piers. Captain Leonard Miller of the 488th Port Battalion supervised the connection of the first floating roadway sections. Each whale unit must be connected with a specialized coupling that allows for 6 feet of tidal movement while maintaining a solid surface for vehicles, he explained to his engineering team. They've never been tested under combat conditions. The engineering challenges were relentless. The Normandy coast experiences tidal ranges of up to 28 feet, among the highest in Europe. This meant the floating piers needed to rise and fall nearly the height of a 3-story building twice daily, while supporting the weight of 40-ton Sherman tanks and fully loaded trucks. Staff Sergeant William Cooper, a former construction foreman from Pittsburgh, directed a team connecting the massive steel spans. We're essentially building the Brooklyn Bridge in the middle of a war zone, he told his men, and we need to finish it before the Germans figure out how to destroy it. The first complete pier was operational by June 11th, 5 days after D-Day. General Clarkson personally inspected the structure, walking the floating roadway as it rose and fell with the waves. Begin unloading operations immediately, he ordered. Priority to ammunition, fuel, and medical supplies. At 2:17 that afternoon, the first vehicle drove directly from a supply ship onto French soil without ever touching water, a 212-ton GMC truck carrying artillery shells for the advancing 1st Infantry Division. The driver, Corporal Henry Makowski from Detroit, would later recall that historic journey. The pier swayed under us like a carnival ride, he noted in his diary. But it held. Engineers were still bolting sections together as we drove past them. One of them shouted, "You're making history, son." I just nodded and kept driving. We had no idea we were part of something that had never been done before. By the end of that first day, the single completed pier had handled 150 tons of supplies, a mere fraction of what was needed, but a proof of concept that boosted morale throughout the beachhead. More importantly, it demonstrated to skeptical military planners that the Mulberry concept was viable. German response was swift but ineffective. On June 12th, a squadron of Junkers Ju-88 bombers attempted to attack the harbour installation, but were intercepted by patrolling Spitfires from the RAF's 41st Squadron. Only 3 German aircraft broke through to the target, and their bombs caused minimal damage to the outer breakwater. Admiral Karl Dönitz, commander of the German Navy, proposed deploying midget submarines against the artificial harbour, but lack of available units and the Royal Navy's vigilant anti-submarine patrols made this impossible to implement quickly. The race against time continued. By June 14th, the American Mulberry had 2 piers fully operational and a third nearing completion. The sheltered anchorage now contained dozens of Liberty ships and smaller vessels discharging their cargoes at a rate of nearly 3.0 tons per day, still far below the required 12 tons, but increasing hourly. On the beaches, the transformation was remarkable. Staff Sergeant Thomas Winters of the 5th Engineer Special Brigade had spent the first days after the landing struggling to move supplies through the surf using amphibious DUKW vehicles, modified 2 1-2-ton trucks that could operate in water. "We were losing 20% of everything to the water," he recalled. "Ammunition boxes breaking open, vehicles stalling in salt water. Now with the harbour operating, it's like we've built a factory assembly line directly to the front." The precisely engineered harbour allowed LST's landing ship tank to discharge directly onto the floating roadways regardless of tide conditions. Each LST could carry up to 20 Sherman tanks or 32 1-2-ton trucks with supplies. Before the Mulberry Harbour, these vessels had to wait for favourable tide conditions and risk grounding on the gradually sloping beaches. Captain Elizabeth Munro, an Army nurse with the 13th Field Hospital, watched the unloading operations with appreciation for what it meant for wounded soldiers. "The first 5 days, we were critically short of everything: plasma, antibiotics, surgical instruments," she noted. "Supplies had to be carried through chest-deep water by medics. Now ambulances drive straight from the ships to our field stations. The difference in survival rates is already measurable." The massive logistical operation was reaching its stride. By June 16th, D-Day +10, the American Mulberry Harbour was handling over 9,000 tons of supplies daily. 3 complete piers were now operational, and a 4th was under construction. The outer breakwater extended over 2 miles, creating a protected artificial harbour larger than Boston's inner harbour. Brigadier General William Hogue, who had supervised much of the American engineering effort, radioed General Eisenhower, "Mulberry are functioning at 75% projected capacity. Expect to reach full operational status within 48 hours." The impossible timeline, constructing a major port in less than 2 weeks, was about to be achieved. German intelligence finally recognized the strategic significance of what the Allies had accomplished. Field Marshal von Rundstedt received a comprehensive assessment from his staff on June 17th. "The Americans have constructed harbour facilities at Omaha Beach, capable of landing approximately 10,000 tons of material daily," the report stated. "This capacity exceeds that of Cherbourg Port during peacetime operations. They have effectively neutralized our strategy of denying them port access." Von Rundstedt forwarded this assessment to Hitler's headquarters with a request for immediate reinforcement of the Normandy front. But the German High Command remained fixated on the possibility that the Normandy landings were merely a diversion, with the main Allied thrust still to come elsewhere. As dawn broke on June 19th, D-Day +13, General Omar Bradley arrived to inspect the completed harbour. What had been an exposed, vulnerable beachhead less than 2 weeks earlier was now a bustling port facility with constant traffic of men and materials moving inland. Bradley's aide recorded his remarks upon seeing the completed installation. "I have witnessed many engineering achievements during this war, but none that has so directly altered the strategic equation as this harbour." That same day, Lieutenant James Barrett, a supply officer with the 29th Infantry Division, documented the harbour's impact in stark numerical terms. We received 500 tons of ammunition, 3,000 tons of fuel, 2,000 tons of rations, and 800 tons of vehicles and equipment in the past 24 hours, he reported. Casualty evacuation is now operating at full efficiency, with wounded reaching field hospitals in England less than 8 hours after leaving the front lines. What the Americans had accomplished was unprecedented in military history, the construction of a major port facility under enemy fire in less than 2 weeks. The completed Mulberry A Harbour extended nearly 3 miles from shore and encompassed over 500 acres of protected anchorage. The floating piers could accommodate 8 Liberty ships simultaneously, along with dozens of smaller vessels. Daily capacity had reached 500 tons, exceeding the original design specifications. The achievement represented the culmination of American industrial might and engineering ingenuity. The harbour components had required 144 tons of concrete, 105 tons of steel, 85 feet of floating bridge sections, 33 tons of steel trusses, 105 tugboats for transportation, 9 engineering troops for assembly. Yet this triumph would prove tragically short-lived. On June 19th, as Bradley completed his inspection tour, weather stations across the English Channel began reporting a developing storm system of unusual intensity for June. Captain James Stagg, the meteorologist who had helped select the original D-Day weather window, delivered the disturbing forecast to Allied headquarters. "We're tracking a developing gale with predicted force 7 winds and wave heights potentially exceeding 15 feet, he reported. The system will reach the Normandy coast within 36 hours. Engineers at both the American and British Mulberry harbours made hasty preparations to secure their structures. The harbour design had included allowances for rough weather, but the approaching storm threatened to exceed those parameters. Lieutenant Commander Philip Mercer, who had witnessed the harbour's arrival 13 days earlier, now supervised emergency reinforcement of the Phoenix-Quezon connections. "Double all mooring lines and verify every connection point," he ordered his teams. "This harbour survived creation. I'll be damned if we lose it to weather." Throughout June 20th, the storm intensified. Supply operations continued at a reduced pace as waves within the harbour enclosure grew to 5 feet. By evening, wind speeds exceeded 45 knots, near hurricane force. General Clarkson ordered all personnel except essential engineering teams to evacuate the harbour structures. At 2:00 a.m. on June 21st, the full fury of the storm struck the Normandy coast. Waves exceeding 20 feet crashed against the outer breakwater. The floating whale piers, designed to ride with the water's movement, were twisted and strained beyond their design limits. Steel bridges buckled under forces equivalent to those that would collapse many civilian bridges. Staff Sergeant Cooper, who had helped build the first pier, was among the skeleton crew that remained on the structure. "It was like being inside a washing machine," he later reported. The entire pier was rising 15 feet and then dropping just as far. Steel sections the size of railroad cars were twisting like paper. By dawn on June 22nd, the extent of the devastation became clear. The American Mulberry A Harbour had been effectively destroyed. Nearly 800 feet of the floating roadway had broken free and smashed against the beach. Several Phoenix caissons had shifted position, creating gaps in the breakwater that allowed devastating wave action to penetrate the harbour area. In one of history's cruel ironies, the American harbour, which had been constructed faster and had achieved higher operating capacity than its British counterpart, proved more vulnerable to the storm. Mulberry B, the British harbour at Gold Beach, suffered significant damage but remained partially operational. General Eisenhower received the damage assessment with characteristic composure. "Salvage what we can," he instructed Bradley, "but we proceed regardless. This harbor served its purpose. It delivered enough supplies to secure our position. Now we accelerate the capture of Cherbourg." Indeed, the strategic situation had fundamentally changed during the 12 days the American Mulberry had operated. The beachhead was now secure enough that conventional beach landings could sustain the advance, albeit with reduced efficiency. More importantly, Allied forces were now close to capturing the port of Cherbourg, the very objective the Mulberry harbors had been designed to bypass temporarily. The human cost of the harbor's construction and operation was significant, but overshadowed by the larger casualties of the invasion. 28 engineers had died during assembly operations, and 34 more during the storm. Yet these losses helped prevent a potentially catastrophic supply failure that could have cost thousands more lives. In the aftermath, German propaganda attempted to portray the harbor's destruction as a victory. Joseph Goebbels' ministry released a statement claiming, "American artificial port facilities have been completely destroyed by German naval action and natural forces, confirming the foolishness of their invasion strategy." The reality, however, was quite different. During its brief operational life, Mulberry A had landed 132, Ruhr-0 troops 22, Ruhr-0 vehicles 139, Ruhr-0 tons of supplies. These figures represented the margin between success and failure for the critical early phase of the Normandy campaign. Captain Richard Crowley, who had led the initial harbour components across the Channel, supervised salvage operations along the battered Omaha beach. Usable sections from the American harbour were transported to Gold Beach to reinforce the British Mulberry B, which would continue operating until November 1944. "We built it in 12 days, it operated for 7, and altered the course of the war forever," Crowley noted in his final report. "No single engineering achievement in this theatre has had more direct strategic impact." The legacy of the Mulberry harbours extended far beyond Normandy. The technology and techniques developed for these artificial ports would influence harbour construction worldwide after the war. The floating bridge designs would be adapted for civilian use in locations from Norway to New Zealand. Even the concrete caisson technology would find application in modern port facilities and offshore oil platforms. For the German military leadership, the Allied artificial harbours represented something more profound, a demonstration of industrial capacity that rendered traditional defensive strategy obsolete. Field Marshal Rommel, upon receiving the final assessment of the Mulberry harbour capabilities, remarked to his staff, "The Americans have not merely projected military power across an ocean, they have moved their industrial capacity across the sea. How does one defeat a nation that can build harbours faster than we can destroy them?" This observation cut to the heart of why the Mulberry harbours represent more than merely a technical achievement. They embodied the American approach to warfare, using overwhelming industrial capacity and engineering innovation to solve problems that others considered insurmountable. As Allied forces pushed inland through the summer of 1944, few soldiers realized how their advance had been made possible by an artificial harbour that existed for just 19 days. 12 days of construction and 7 days of operation. Yet without those crucial days of supply flow, the entire invasion might have stalled on the beaches. Lieutenant Commander Philip Mercer, who had witnessed both the harbour's arrival and its destruction, perhaps best summarized its significance in a letter to his wife. "What we built here was technically a temporary port facility, but its real cargo wasn't tanks or ammunition. It delivered certainty, the certainty that once American boots touched French soil, nothing would remove them. When you can build harbours where nature intended none to exist, you fundamentally change the rules of warfare." Today, few visible traces remain of Mulberry A along Omaha Beach. Occasional concrete fragments can be spotted at extreme low tide, the last physical evidence of an engineering miracle that helped change the course of World War II by building an entire harbor in just 12 days. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.